Hi folks, so in this video here what we're going to do is complete two questions here based on the topic of rotational solids, and it comes under the area of orthographic projection. These are from the DCG Solutions workbook, and this one here is focused on a hexagon, whereas we have a hexagonal based pyramid here. So starting with the hexagon, just going to zoom in on that one here now. We'll start that. So this is kind of a little bit of an advancement from junior cyclographics. So if we just read the question, it says here the base of the hexagon prism, or the base of the hexagon prism shown is tilted at 30 degrees to the horizontal plane. So a little bit of information there. What does that mean? That means that the base of the prism, if you look at it here, it's actually tilted up, so it's not sitting flat anymore. It's kind of like we took it and we tilted it at a 30-degree angle to the horizontal plane. What does that mean? The horizontal plane essentially means it has been tilted up at an angle in relation to the ground. Now, where is our ground? Our ground is the XY line. So I'll just put that here, X and Y, that is our ground. Okay, it says here, and is 60 millimeters in height. The plan shows the base of this prism when resting on the horizontal plane. So this is what the plan of the prism would look like when it is sitting perfectly flat on the ground. Draw the plan and elevation and end view of the prism when it is rotated about the edge AB. Okay, so what we're going to do is we're going to start off by drawing this prism as if it was just flat first of all. So all 6 points that are on the base would literally come straight up. So AB will come up, and it has a height as well. So this will come up, and this edge would also come up. Now, all I'm going to do here is I'm going to measure up 60 millimeters because that's the overall height. So using my 10 up as far as 16, that's 60 millimeters. Project the line across. So there we have our prism when it is up at that height. Now, for demonstration purposes, I'm just going to put in the letter C, D, E, and F. Okay, so the edge AB on the ground would be here. I'd have B at the front, A at the back. This one would be C at the front, F at the back, and finally I have D at the front and E at the back. So it goes inside. Okay, so there we have it. That is exactly what our prism would look like when we're looking directly at it. Okay, so if I just take you into a SolidWorks model here, there's our prism, and if we look at the front view of the object, that's what it looks like. Okay, if I just go into the display style here and put it in that way, that's exactly what we see. There's our 3 vertical lines, and then we've got our 2 horizontal lines at the top. It looks the exact same as this guy right here. Now, what they've told us is that the question here says the base of the hexagon prism shown is tilted at 30 degrees to the horizontal plane. Okay, so what does that mean? If we go back into the SolidWorks model here, and I'm going to put back on the color. Okay, essentially, if you imagine there's a ground line here, that is the XY line, and it's tilted at 30 degrees. So what we're going to do up here is we're going to do a move body. Okay, so I'm going to go in here, and yeah, I'm going to move this body. Here's the object, and my rotation line is going to be this guy here. That's my edge AB, that line there. Okay, and what I want to do is I'm going to go back to the front view, and all that's going to happen is it's going to rotate about this point. So watch what everything happens here. As I move it, it's going to slowly move, and you can see it's starting to move there, and I want to keep moving it until it gets to 30 degrees. Okay, so there we have the object. It has been rotated, and now the base is not sitting flat on the ground anymore. It is up at a 30-degree angle. I'm going to accept that, and that's what our object looks like. So it went from this position, and it's after rotating up about that point at the corner here at a 30-degree angle. Now, how does that change what it looks like in our drawing? That's what we have to do. So in the elevation, we're going to see this shape, but in the plan view, I'm going to see this. Okay, so in the plan, when I'm looking down on top of it, I'm going to see that shape there. I think I have it tilted the wrong way there in relation to our sheet. Yeah. This is the side we'll kind of be looking down on top of it there. If I come down and I look there directly on top, that's the shape that we're going to see. And obviously then we would have some hidden details involved in it as well. Okay, so that's the question, and that's the idea. So all we're going to do now is AB is going to be our hinge line. As everything rotates, all the points on the object are going to rotate as well to an angle of 30 degrees. So if I get my set square, put it on AB using my 30-degree set square, I'm going to do a line, and that line there is at 30 degrees in relation to the horizontal plane, the ground. Now I'm going to rotate the points. A and B is my fixed point. I'm going to bring them in until it gets to D and E. I'm going to rotate until it comes up. I'm going to do the same with F and C until it comes up. Okay? Now what I often say inside in class is, how do I get an angle that is going to be perpendicular to the 30 degrees? Well, all I have to do there really is add 30, what do I add to 30 to bring it to 90? So this angle is at 30, 30 plus what makes 90, 30 plus 60. So all I'm going to do now is I'm going to go up at 60 degrees. That'll be perpendicular from this point, because F and C has moved up to this position now as well. As it rotated, the edge rotated with it, and there we go. So that's my rotation lines. So it's like I'm after tilting it up, and now I have to find the new points here at the top. So it's the exact same thing. Now I only need to find one of them. So using A and B as my hinge line, or hinge point I should say, I'm going to find this one here. Make sure I have it. Yep. I rotate that. You can see it hits right there at the top, and that line there that's coming down here has to be parallel to this one, because it's perpendicular to the 60, so 60 plus 30 makes 90. And there we go. So I've now drawn in my prism when it has been tilted 30 degrees to the horizontal plane. Just really quickly, heavying this in with my marker. And here we go. So there is the elevation. Now I have to get the new position of the plan. So everything has moved now. Okay, so in the plan I'm looking directly down on top of it, so I would see the actual hexagon here. So I'm going to get that first. So this guy is going to come down. It'll be very close to it. Actually looks like it's bang on it. That's pretty close. We'll get this one down. And this one. Okay. Now all that's going to happen is, as it moves, the new positions of A and B is probably, this point's there on the ground, but the top points, okay, they're all going to move out as well. So from these points here, they're going to come out, and out there, and there. And all we're going to do is we're going to locate those points. So those points are, from the top of it, I've got 2 points here, and here. Another point there and there. They're the outside points. And here. So that there is my hexagon shape on top. So there's the one on top. So I can see that surface there on top, and now it's about finding the surface on the bottom and then connecting up the faces down along the length. So to find the points at the bottom, well, D and E are not here anymore. They're going to be somewhere along these lines, but the new position of D and E was when I moved up to here. So I'm bringing it down, and I can find the edge for the new position for D and the new position for E. I'm going to find the new position for F and C, which was originally here. It's now here. So let's find those. There's F, there's C, and then the base is still in the same position. So it's just a case of heavying that outline detail. There we go. And there's that one. And now I'm going to heavy in the faces that we can see. So I can see this face, I can see this face. As I'm looking down on top of it at an angle, I can see that face, I can see the outside faces. Now we just have to heavy in the hidden details, and there'll be faces here that I can't see. So as they run down, bit of hidden detail there, bit of hidden detail here. And then the hexagon at the bottom, it's the exact same. Just making sure, yeah. There's that one, and then connecting up to this one. And there we go. So that's what it looks like when we look down top of it in the plan view. So if I just refer back to my SolidWorks model here, okay, and if I put in the color mode, there's the top face, okay, there's the side face, side face, side face, and obviously then if I put in the hidden detail view, we can see the base down underneath it, that's the base, and then obviously I've got the faces at the back as well. Okay, so that's our object as we look down on top of it, and it has been tilted 30 degrees to the horizontal plane. So if I look at it straight on again there, you can see it, and then as I tilt it around, there we go. Sorry, I actually tilted that the wrong way. This way. There we go. Okay, so now we're going to move on to the next question here at the bottom of the page. So that's the first one done. Oh, I apologise, completely forgot to do the end elevation. So to get the end elevation, all we're going to do, no rules of orthographic, apologies, 45 degrees from here. All my lines are now going to come over, over, so there's my 4 points that have come over on the ground. It's going to go up, 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 and up. So it's going to be somewhere up along those 4 lines for the end elevation. And now I have to find, remember, it's like we're looking at it in from this direction here. So it's like I'm over here in the elevation looking in at it. So if I was a person standing here looking in this direction, yes, I would see underneath it a little bit, and I'll see all this face. The hexagon I actually can't see is the one here at the top, at the back. So as I'm looking in this direction, okay, I can see underneath it, but I can't see over it. So I have to project those heights across now. So this will come across here. This one comes across. I'll do the same with the top one. Have it ready. It's actually in the middle, so I need to go out the whole way. This one. Okay, that's the exact same thing, just heavying in the correct parts. So, sorry, get the right ones. So that's my base hexagon, which I can fully see. And then I'm going up as far as here. That'll be in hidden detail. So, just to heavy this in. That's heavy. That's heavy. 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 And heavy in the details in here then. This is the bit we can see, as I said, as it's tilted away from us. Same at the top. And hidden detail here at the back. And that's showing the hexagon at the top surface. Okay, and there we have it. So if I just really quickly refer out to our SolidWorks model here, that was the top of it. And if we go back down, this time it's like we were looking at it from this direction. Okay, but back on the colour, that's what we were looking at. So we had it originally in the front, then we had it on the top, looking down on top of it, or something like that. Back to the front, okay, something like that, and then rotate it around. And that's kind of like we're looking at something there. Okay, and that's the idea. Okay, so I'm going to save that one. Now what we're going to do is we're going to move on to the next question here, which is the hexagonal pyramid. So getting onto the hexagonal pyramid here. It says here, given is the plan of a hexagonal base pyramid which has an altitude of 50 millimeters. So that means the height of it is 50 millimeters. The solid is to be rotated until surface X, which we can see here in the plan, rests on the horizontal plane. So we're going to have to rotate it until it hits the horizontal plane. Draw the plan elevation of the pyramid when rotated. Okay, so starting off, very similar to the last question, we're going to start off by projecting our points up to the elevation. And the apex, which is this point here in the middle, is going to go up there, and we're going to measure 50 millimeters above the XY line to get the height of it overall. So as far as here, and we'll always draw on the cone, or sorry, not the cone, the pyramid, as we imagine it would be drawn when it's sitting flat on the ground. Okay, So that's what our pyramid would look like. Technically, this view that I have here right now is when we're looking directly in here. So technically, I can see this face here and this face. I'm going to use labels once again. So I'm going to call this point here, I'm going to say A, B, C, D, E, and F. And in elevation, well then I'd have A and B, or sorry, it should actually be B first. A on the inside. I'd have C and F, just going to put them there. And then I'd have D with E. Okay, and there's my points as I'm looking in. Now, it tells us here, the solid is to be rotated until surface X, which is this surface here. Okay, I'll actually label the top point, O as well. Okay, until surface X rests on the horizontal plane. So how do we do that? We want to rotate until this triangular surface ABO is sitting on the ground. And if you look at ABO in elevation, that is an edge view where we see it as a line in elevation. Okay, we're going to rotate that until it's on the ground on the XY line here. Okay, so if we just go out to the SolidWorks model really quickly here. So here's our cone, or sorry, our pyramid again. I keep saying cone. Here's our pyramid, and if we look at it from the front view, that's what we're seeing. And this point right here is our edge AB. There's our edge, AB, okay? But when we look at an elevation, we see AB as a point. Now we want to hinge it around until this face here, that I've highlighted in blue, is sitting on the ground. So how am I going to do that? Same thing as I did last time, move body copies. I'm going to go into, I'm going to move the whole body, and I'm going to set about my rotation line, which is this point right here. That's my rotation line. Now, I'm going to go back out to the front view. This is what it's looked like. And all I'm going to do is I'm going to rotate it, and you can see it's starting to rotate there. And notice how these 2 points, this one and this one, are starting to just literally curve up around it. So I'll go a little bit quicker here now. And you can see that there. And I want to keep rotating it until it falls down flat on the ground. We just keep going. There we go. Okay, so that's what it's going to look like. So accept that there now. So in stage 1 it was like this, and then in stage 2 we rotate it and it looks like this. Okay, where the same point here stays the same, AB, and it's going to rotate until that surface here sits on the ground. Okay, and you can see there in relation to where it went, that surface there is rotated. Okay, so that's the idea. So how do we represent that? So we've drawn it in elevation, we have it in plan. All we're going to do is we're going to hinge it around. So we're going to use our compass. AB is our hinge point. I'm going to rotate O all the way around until it comes onto the ground. So the new position of O is here. Okay, now this next bit is a little bit tricky. AB is going to stay in the same position. So because AB stays in the same position, but everything else, the base of it is going to move up, well then E and D are also going to move up. So E and D will rotate up like this. Okay, and somewhere up along that rotation is going to be E and D. And likewise with C and F. Going to be somewhere up there along that. Now how do I find the exact position of E and D? I already have the position of A, B and O. That line there, A, B, O, which was originally here, is now here. So what I can actually do is, because I have the position of O, the new position of O, I can take the distance from O down to ED. Take that distance there on my compass, and I can go to my new position for O, and where it's cut through the arc, the ED arc, I can find it. All I do then is simply connect this point back to AB, and then connect it to O, and then this point C and F, when it rotates around, it has to be on that line there. So there we go, follow it around, and that there is the new position of my cone. I keep saying cone, sorry, pyramid, when it is resting on the horizontal plane, when surface X is resting on the horizontal plane. So that head bit in there. There's the edge here. So there we have it, guys. Now all we're going to do is we have to draw the plan view of that. So A and B will still be in the same position. I want to find the new position of O. So on plan, O just comes straight down. O is now going to go across. Okay, A and B will be in the same position. But if I want to find C and F, well, C and F's new position is here. So if I bring this position, this line down, okay, and to find it, well, C comes out, F comes out. Well, F is already out there. So there's the new position for C, which connects to B, connects to A. There's the new position for F. And I should put O out here as well while I'm at it. Okay, and now I want to find the new position for E and D, which was here. Now I need to find it down here. So D comes out, E comes out. And simply a case of finding them. There we go. Now what we have to understand, there's D, there's E. What we just have to understand is when we're looking down on top of it now, okay, in the plan view, when I'm above in the sky looking down top, yes, I can see that hexagonal face. I'll also see this face, the face there, and I'll see 3 faces around the side with some hidden detail. So if I get that hexagon heavied in first, A and B, okay, so that's the hexagon as we see it. And we look down on top. There we go. And all those points then are going to connect to the apex. So I can see C, I can see the edge D, I can see O to E, and finally O to F. Okay, now the edge A to O and B to O, just because I see them does not mean that they're not there, so they'll also go in as hidden detail. Because that actually is representing my surface X, which is on the ground, and because it's on the ground, all the other part of the object is in front of it. So that there, that triangle ABO, is the one that's resting on the ground. Okay, so there you have it, folks. That there is the question complete. If I just go really quickly back out to SOLIDWORKS model, and if we look at the front view, well, that's what it looks like when it's resting on the ground. And if I look down at the bird's eye view, I'll actually rotate it. And there we go. That's what we see. And if we go into the hidden detail, it's the exact same as we have in our sheet. Okay, exact same. So there we have it, folks. That is the 2 questions there completed on the rotation of solids, one based on a prism and the other one based on a hexagonal pyramid. Hope you found those helpful.